In this video, we are going to continue our discussion over the section of the dot product with something called vector projection. Okay, so the vector PR, so take a look here. Let's get our mind around this picture. We have vector A starting at P going up to Q, right? And then we have this other vector, and this is what they're talking about. The vector PR, so that's this vector right here, PR. Right, that A creates in the direction of B is called the vector projection. It's labeled like this. How you say this? This is the projection of A onto B. What that is, it would be like if I had sunshine coming down, right? It would be the shadow if the sun was directly above. So that's what we're looking at is high noon sun, right at the top, looking down on some kind of incline. It's the projection of the shadow onto the ground or onto the vector we're talking about. So how we write this is it says how we say it, projection of A onto B. Projection of A onto B. Okay, so we're going to move forward and I'm going to show you how to come up with that projection. How do I come up with PR if I was given A and then B? B is this big vector here, if you didn't notice. B is the big vector. We are actually putting sunshine on A, looking down onto B, and the vector we're interested in is the shadow from A onto B. All right, the magnitude of this projection, this is the projection here, the magnitude of that is called the component projection. We write it right here. So I'm going to write that. Component of A onto B. That is that orange side there. We also have this side. Now remember, if I want the length of this side, it is the magnitude of A, not A. Right? The comp down there is a number. It's an actual number. I want to write a ratio involving the green magnitude of A and then the component projection and using theta. We can do this with trig. That is a cosine angle. All right, so cosine is adjacent, which is that comp of A onto B divided by the hypotenuse, which is the magnitude of A. That's just trig. Cosine is adjacent over hypotenuse. Now solving for comp, let's go ahead and do that. So the component projection of A onto B is equal to the magnitude of A times cosine of theta. Okay, this is because cosine is x, and we're only dealing with positive, and we only want that one quadrant. So we're going to say theta is between 0 and pi over 2. We just want that one quadrant. I don't want to go above it. If anything, if it got above, we'd be dealing with this side, and it's the same idea. So we have that. Now, since, and maybe this is from the last video, the cosine of theta, this is this definition, the angle between two vectors definition, u dot b over their magnitudes, the product of their magnitudes. So we have that. So since that's true, we have, and what we can do, and we're going to replace it with a's and b's, not u's and b's, but I'm going to take this line here and replace cosine. So that tells me that comp, or the component projection of A onto B, is equal to, okay, so we get magnitude of A times, and then it's all of this, A dot B over the magnitude of A times the magnitude of B, and we have that. All right, this actually cancels the magnitude of A, leaving the component projection to be A dot B over the magnitude of B. So there's our definition for that. Now I want you to recall, and we're going to work our way into that projection. Recall that vectors are made up of two things. Vectors are a magnitude. It's a magnitude times a direction. Right? In this case, so the projection of A onto B. Okay, now this one you're going to have to bear with me. If I want that projection, that's what's in orange here, I know that the comp, the component is a magnitude almost. It's like it's a measure of that side. It tells me how long that side is, right? It's the magnitude. It's a scalar. So it is a magnitude, right? So the magnitude in this case is going to be my component projection. That is the magnitude, right? That's the way that that component is actually even defined. Times a direction, well, I have the direction. The direction, if I look, I want that direction to be in the direction of B. So I'm going to times it by B. Now, I can fill in what I know. I know that that comp of A onto B is A dot B over B. Okay, and then actually I should have done this. Let's go back up here real quick. That B, I want the direction of B. So what we really should do is we should find the unit vector for B. So that right there, what we just wrote down here, this is the unit vector in the direction of B. The component projection of A onto B is a magnitude. The unit vector itself on the right is a direction. So this is times B vector, and then I have the magnitude of that. Okay, now I'm going to rearrange this. This is A dot B over the magnitude of B squared times B. That is my definition of a projection. Now, there's a couple things I want to point out because these are extremely difficult to remember which one's which, because I could flip A and B and we'll figure it out. It's different. And the next example shows us that they're different. But how can I remember this? This is A on to B. So this makes sense. If we're going on to B, it makes sense that A would only show up one time. B's are the rest. So to help you memorize the projection of A on to B, B is the one that we're trying to go to. So it makes sense that we have more B's. So again, this is like the shadow being projected onto B from A. It's just a shadow. All right, so let's work on, this is a very important definition. I did not put it in a box for you, I don't think. I did not, so you may want to star that, circle it, whatever you need. That is the actual definition. All right, let's do a few examples. All right, I'm going to write the formula at the top. So the projection of A onto B is the dot product of A and B divided by the magnitude of B squared times the vector B to put it in that direction. Okay, so I'm going to write out these in component form because I feel more comfortable in component form. That's up to you. I got 1, 2, 3. And then I got B vector is 2, negative 1, 1. And the first thing I need in my formula, I always do these in pieces. So A dot B, oh, we got to be very careful here. Notice what they're asking for. Let me erase what's there, and I like to write it out to help myself. Projection, and now they're doing B onto A. So I'm going to write out the definition. The B only shows up one time, and then the rest are A's. There we go. Okay, so I like to do piece by piece. So let's do this. B dotted with A. Handwriting is getting progressively worse. I apologize. It'll be better. I'll get a new Apple Pencil tip. It's affecting it some. Okay, doing my dot there. All right, I multiply 1 times 2 is 2. Then I add that with 2 times negative 1 is negative 2. Then I add that to 3 times 1, which is 3. That means the dot product is 3. Right? I also need the magnitude of A squared, though. Remember, this is A dot A. So that helps. All right, so I dot 1 times 1 is 1, plus 2 times 2 is 4, times 3 is 9, and we get 14. All right, so that means the projection of A onto B is, all right, so it's going to be 3 over 14 times vector A, which is 1, 2, 3. So that is the projection. So if we had vector B and we were shining a light down on vector B that had A underneath it, this would be the shadow under B. Right? Not too bad. I think the most difficult part is remembering this giant formula. I think that's the worst part. Right? We're going to do it the other way just to show ourselves that they are different. So the projection of A onto B this time, the other way. I write out the definition. So I got A dotted with B over the magnitude of B squared times B. All right, I'm going to write down A and B again. A is, I have it written down here, 1, 2, 3. And B is 2, negative 1, 1. I already have the dot product, A dot B. It's the same thing as B dot A. What did we say that was? We said it was 3. So now all I need is the magnitude of A squared, which is just A dot A. All right. So dotting A, we got, I feel like that's what we did on the last one. Oh, we need B. Okay, so B here. And we got B dot B. So looking at B, I got 4 plus 1 plus 1, which is 6. So the projection of A onto B is going to be 1/2 times, we don't even need the parentheses, times vector B, which is 2, negative 1, 1. That is the projection of A onto B. Like I said, the worst part of these will be the formula and trying to remember it. Outside of that, they're just dot products and magnitudes. Nothing too crazy.